Wormholes and time travel. The last chapter discussed why we see time go forward, why disorder increases, and why we remember the past but not the future. Time was treated as if it were a straight railway line on which one could only go one way or the other. But what if the railway line had loops and branches so that a train could keep going forward but come back to a station it had already passed? In other words, might it be possible for someone to travel into the future or the past? H.G. Wells in The Time Machine explored these possibilities, as have countless other writers of science fiction. Yet many of the ideas of science fiction, like submarines and travel to the moon, have become matters of science fact. So what are the prospects for time travel? The first indication that the laws of physics might really allow people to travel in time came in 1949, when Kurt Gödel discovered a new space-time allowed by general relativity. Gödel was a mathematician who was famous for proving that it is impossible to prove all true statements, even if you limit yourself to trying to prove all the true statements in a subject as apparently cut and dried as arithmetic. Like the uncertainty principle, Gödel's incompleteness theorem may be a fundamental limitation on our ability to understand and predict the universe, but so far at least it hasn't seemed to be an obstacle in our search for a complete unified theory. Gödel got to know about general relativity when he and Einstein spent their later years at the Institute for Advanced Study in Princeton. His space-time had the curious property that the whole universe was rotating. One might ask, rotating with respect to what? The answer is that distant matter would be rotating with respect to directions that little tops or gyroscopes point in. This had the side effect that it would be possible for someone to go off in a rocket ship and return to Earth before he set out. This property really upset Einstein, who had thought that general relativity wouldn't allow time travel. However, given Einstein's record of ill-founded opposition to gravitational collapse and the uncertainty principle, maybe this was an encouraging sign. The solution Gödel found doesn't correspond to the universe we live in, because we can show that the universe is not rotating. It also had a non-zero value of the cosmological constant that Einstein introduced when he thought the universe was unchanging. After Hubble discovered the expansion of the universe, there was no need for a cosmological constant, and it is now generally believed to be zero. However, other more reasonable spacetimes that are allowed by general relativity and which permit travel into the past have since been found. One is in the interior of a rotating black hole. Another is a space-time that contains two cosmic strings moving past each other at high speed. As their name suggests, cosmic strings are objects that are like string in that they have length, but a tiny cross-section. Actually, they are more like rubber bands because they are under enormous tension, something like a million tons. A cosmic string attached to the Earth could accelerate it from 0 to 60 miles per hour in 1/30th of a second. Cosmic strings may sound like pure science fiction, but there are reasons to believe they could have formed in the early universe as a result of symmetry breaking of the kind discussed in Chapter 5. Because they would be under enormous tension and could start in any configuration, they might accelerate to very high speeds when they straighten out. The Gödel solution and the cosmic string spacetime start out so distorted that travel into the past was always possible. God might have created such a warped universe, but we have no reason to believe he did. Observations of the microwave background and of the abundances of the light elements indicate that the early universe did not have the kind of curvature required to allow time travel. The same conclusion follows on theoretical grounds if the no-boundary proposal is correct. So the question is, if the universe starts out without the kind of curvature required for time travel, can we subsequently warp local regions of space-time sufficiently to allow it? A closely related problem that is also of concern to writers of science fiction is rapid interstellar or intergalactic travel. According to Relativity, nothing can travel faster than light. If we therefore sent a spaceship to our nearest neighboring star, Alpha Centauri, which is about 4 light years away, it would take at least 8 years before we could expect the travelers to return and tell us what they had found. If the expedition were to the center of our galaxy, it would be at least 100,000 years before it came back. The theory of relativity does allow one consolation. This is the so-called twins paradox, mentioned in Chapter 2. Because there is no unique standard of time, but rather observers each have their own time as measured by clocks that they carry with them, it is possible for the journey to seem to be much shorter for the space travelers than for those who remain on Earth. But there would not be much joy in returning from a space voyage a few years older to find that everyone you had left behind was dead and gone thousands of years ago. So in order to have any human interest in their stories, science fiction writers had to suppose that we would one day discover how to travel faster than light. What most of the authors don't seem to have realized is that if you can travel faster than light, the theory of relativity implies you can also travel back as the following limerick says, "There was a young lady of white who traveled much faster than light. She departed one day, in a relative way, and arrived on the previous night." The point is that the theory of relativity says that there is no unique measure of time that all observers will agree on. Rather, each observer has his or her own measure of time. If it is possible for a rocket traveling below the speed of light to get from event A, say the final of the 100-meter race of the Olympic Games in 2002, to event B, say the opening of the 100,004th meeting of the Congress of Alpha Centauri, then all observers will agree that event A happened before event B according to their times. Suppose, however, that the spaceship would have to travel faster than light to carry the news of the race to the Congress. Then observers moving at different speeds can disagree about whether event A occurred before B or vice versa. According to the time of an observer who is at rest with respect to the Earth, it may be that the Congress opened after the race. Thus, this observer would think that a spaceship could get from A to B in time, if only it could ignore the speed of light speed limit. However, to an observer at Alpha Centauri, moving away from the Earth at nearly the speed of light, it would appear that event B, the opening of the Congress, would occur before event A, the 100-meter race. The theory of relativity says that the laws of physics appear the same to observers moving at different speeds. This has been well tested by experiment and is likely to remain a feature even if we find a more advanced theory to replace relativity. Thus, the moving observer would say that if faster-than-light travel is possible, it should be possible to get from event B, the opening of the Congress, to event A, the 100-meter race. If one went slightly faster, one could even get back before the race and place a bet on it in the sure knowledge that one would win. There is a problem with breaking the speed of light barrier. The theory of relativity says that the rocket power needed to accelerate a spaceship gets greater and greater the nearer it gets to the speed of light. We have experimental evidence for this, not with spaceships, but with elementary particles in particle accelerators like those at Fermilab or CERN, European Centre for Nuclear Research. We can accelerate particles to 99.99% of the speed of light, but however much power we feed in, we can't get them beyond the speed of light barrier. Similarly with spaceships, no matter how much rocket power they have, they can't accelerate beyond the speed of light. That might seem to rule out both rapid space travel and travel back in time. However, there is a possible way out. It might be that one could warp space-time so that there was a shortcut between A and B. One way of doing this would be to create a wormhole between A and B. As its name suggests, a wormhole is a thin tube of space-time which can connect two nearly flat regions far apart. There need be no relation between the distance through the wormhole and the separation of its ends in the nearly hat background. Thus, one could imagine that one could create or find a wormhole that will lead from the vicinity of the solar system to Alpha Centauri. The distance through the wormhole might be only a few million miles, even though Earth and Alpha Centauri are 20 million miles apart in ordinary space. This would allow news of the 100-meter race to reach the opening of the Congress. But then, an observer moving towards 6 EE Earth should also be able to find another wormhole that would enable him to get from the opening of the Congress on Alpha Centauri back to Earth before the start of the race. So wormholes, like any other possible form of travel faster than light, would allow one to travel into the past. The idea of wormholes between different regions of space-time was not an invention of science fiction writers, but came from a very respectable source. In 1935, Einstein and Nathan Rosen wrote a paper in which they showed that general relativity allowed what they called bridges, but which are now known as wormholes. The Einstein-Rosen bridges didn't last long enough for a spaceship to get through. The ship would run into a singularity as the wormhole pinched off. However, it has been suggested that it might be possible for an advanced civilization to keep a wormhole open. To do this, or to warp space-time in any other way so as to permit time travel, one can show that one needs a region of space-time with negative curvature, like the surface of a saddle. Ordinary matter, which has a positive energy density, gives space-time a positive curvature, like the surface of a sphere. So what one needs in order to warp space-time in a way that will allow travel into the past is matter with negative energy density. Energy is a bit like money. If you have a positive balance, you can distribute it in various ways. But according to the classical laws that were believed at the beginning of the century, you weren't allowed to be overdrawn. So these classical laws would have ruled out any possibility of time travel. However, as has been described in earlier chapters, the classical laws were superseded by quantum laws based on the uncertainty principle. The quantum laws are more liberal and allow you to be overdrawn on one or two accounts provided the total balance is positive. In other words, quantum theory allows the energy density to be negative in some places, provided that this is made up for by positive energy densities in other places, so that the total energy remains positive. An example of how quantum theory can allow negative energy densities is provided by what is called the Casimir effect. As we saw in Chapter 7, even what we think of as empty space is filled with pairs of virtual particles and antiparticles that appear together, move apart, and come back together and annihilate each other. Now, suppose one has two parallel metal plates, a short distance apart. The plates will act like mirrors for the virtual photons or particles of light. In fact, they will form a cavity between them, a bit like an organ pipe that will resonate only at certain notes. This means that virtual photons can occur in the space between the plates only if their wavelengths, the distance between the crest of one wave and the next, fit a whole number of times into the gap between the plates. If the width of a cavity is a whole number of wavelengths plus a fraction of a wavelength, then after some reflections backward and forward between the plates, the crests of one wave will coincide with the troughs of another, and the waves will cancel out. Because the virtual photons between the plates can have only the resonant wavelengths, there will be slightly fewer of them than in the region outside the plates where virtual photons can have any wavelength. Thus, there will be slightly fewer virtual photons hitting the inside surfaces of the plates than the outside surfaces. One would therefore expect a force on the plates, pushing them toward each other. This force has actually been detected and has the predicted value. Thus, we have experimental evidence that virtual particles exist and have real effects. The fact that there are fewer virtual photons between the plates means that their energy density will be less than elsewhere. But the total energy density in empty space far away from the plates must be zero, because otherwise the energy density would warp the space and it would not be almost flat. So, if the energy density between the plates is less than the energy density far away, it must be negative. We thus have experimental evidence both that space-time can be warped from the bending of light during eclipses and that it can be curved in the way necessary to allow time travel from the Casimir effect. One might hope, therefore, that as we advance in science and technology, we would eventually manage to build a time machine. But if so, why hasn't anyone come back from the future and told us how to do it? There might be good reasons why it would be unwise to give us the secret of time travel at our present primitive state of development. But unless human nature changes radically, it is difficult to believe that some visitor from the future wouldn't spill the beans. Of course, some people would claim that sightings of UFOs are evidence that we are being visited either by aliens or by people from the future. If the aliens were to get here in reasonable time, they would need faster than light travel, so the two possibilities may be equivalent. However, I think that any visit by aliens or people from the future would be much more obvious and probably much more unpleasant. If they are going to reveal themselves at all, why do so only to those who are not regarded as reliable witnesses? If they are trying to warn us of some great danger, they are not being very effective. A possible way to explain the absence of visitors from the future would be to say that the past is fixed because we have observed it and seen that it does not have the kind of warping needed to allow travel back from the future. On the other hand, the future is unknown and open, so it might well have the curvature required. This would mean that any time travel would be confined to the future. There would be no chance of Captain Kirk and the Starship Enterprise turning up at the present time. This might explain why we have not yet been overrun by tourists from the future. But it would not avoid the problems that would arise if one were able to go back and change history. Suppose, for example, you went back and killed your great-great-grandfather while he was still a child. There are many versions of this paradox, but they are essentially equivalent. One would get contradictions if one were free to change the past. There seem to be two possible resolutions to the paradoxes posed by time travel. One I shall call the consistent histories approach. It says that even if space-time is warped so that it would be possible to travel into the past, what happens in space-time must be a consistent solution of the laws of physics. According to this viewpoint, you could not go back in time unless history showed that you had already arrived in the past and while there had not killed your great-great-grandfather or committed any other acts that would conflict with your current situation in the present. Moreover, when you did go back, you wouldn't be able to change recorded history. That means you wouldn't have free will to do what you wanted. Of course, one could say that free will is an illusion anyway. If there really is a complete unified theory that governs everything, it presumably also determines your actions, but it does so in a way that is impossible to calculate for an organism that is as complicated as a human being. The reason we say that humans have free will is because we can't predict what they will do. However, if the human then goes off in a rocket ship and comes back before he or she set off, we will be able to predict what he or she will do because it will be part of recorded history. Thus, in that situation, the time traveler would have no free will. The other possible way to resolve the paradoxes of time travel might be called the alternative histories hypothesis. The idea here is that when time travelers go back to the past, they enter alternative histories which differ from recorded history. Thus they can act freely without the constraint of consistency with their previous history. Steven Spielberg had fun with this notion in the Back to the Future films. Marty McFly was able to go back and change his parents' courtship to a more satisfactory history. The alternative histories hypothesis sounds rather like Richard Feynman's way of expressing quantum theory as a sum over histories, which was described in chapters 4 and 8. This said that the universe didn't just have a single history, rather it had every possible history, each with its own probability. However, there seems to be an important difference between Feynman's proposal and alternative histories. In Feynman's sum, each history comprises a complete space-time and everything in it. The space-time may be so warped that it is possible to travel in a rocket into the past, but the rocket would remain in the same space-time and therefore the same history, which would have to be consistent. Thus, Feynman's sum over histories proposal seems to support the consistent histories hypothesis rather than the alternative histories. The Feynman sum over histories does allow travel into the past on a microscopic scale. In Chapter 9, we saw that the laws of science are unchanged by combinations of the operations C, P, and T. This means that an antiparticle spinning in the anti-clockwise direction and moving from A to B can also be viewed as an ordinary particle spinning clockwise and moving backward in time from B to A. Similarly, an ordinary particle moving forward in time is equivalent to an antiparticle moving backward in time. As has been discussed in this chapter and Chapter 7, empty space is filled with pairs of virtual particles and antiparticles that appear together, move apart, and then come back together and annihilate each other. So, one can regard the pair of particles as a single particle moving on a closed loop in space-time. When the pair is moving forward in time, from the event at which it appears to that at which it annihilates, it is called a particle. But when the particle is traveling back in time from the event at which the pair annihilates to that at which it appears, it is said to be an antiparticle traveling forward in time. The explanation of how black holes can emit particles and radiation, given in Chapter 7, was that one member of a virtual particle/antiparticle pair, say the antiparticle, might fall into the black hole, leaving the other member without a partner with which to annihilate. The forsaken particle might fall into the hole as well, but it might also escape from the vicinity of the black hole. If so, to an observer at a distance, it would appear to be a particle emitted by the black hole. One can, however, have a different but equivalent intuitive picture of the mechanism for emission from black holes. One can regard the member of the virtual pair that fell into the black hole, say the antiparticle, as a particle traveling backward in time out of the hole. When it gets to the point at which the virtual particle-antiparticle pair appeared together, it is scattered by the gravitational field into a particle traveling forward in time and escaping from the black hole. If, instead, it were the particle member of the virtual pair that fell into the hole, one could regard it as an antiparticle traveling back in time and coming out of the black hole. Thus, the radiation by black holes shows that quantum theory allows travel back in time on a microscopic scale, and that such time travel can produce observable effects. One can therefore ask, does quantum theory allow time travel on a macroscopic scale, which people could use? At first sight, it seems it should. The Feynman sum over histories proposal is supposed to be over all histories. Thus, it should include histories in which space-time is so warped that it is possible to travel into the past. Why then aren't we in trouble with history? Suppose, for example, someone had gone back and given the Nazis the secret of the atom bomb. One would avoid these problems if what I call the chronology protection conjecture holds. This says that the laws of physics conspire to prevent macroscopic bodies from carrying information into the past. Like the cosmic censorship conjecture, it has not been proved, but there are reasons to believe it is true. The reason to believe that chronology protection operates is that when space-time is warped enough to make travel into the past possible, virtual particles moving on closed loops in space-time can become real particles traveling forward in time at or below the speed of light. As these particles can go round the loop any number of times, they pass each point on their route many times. Thus, their energy is counted over and over again, and the energy density will become very large. This could give space-time a positive curvature that would not allow travel into the past. It is not yet clear whether these particles would cause positive or negative curvature, or whether the curvature produced by some kinds of virtual particles might cancel that produced by other kinds. Thus, the possibility of time travel remains open, but I'm not going to bet on it. My opponent might have the unfair advantage of knowing the future. The concept of time travel has fascinated humanity for centuries, blending the realms of science fiction and theoretical physics. The passage you provided delves into the scientific possibilities and paradoxes associated with time travel, particularly through the lens of general relativity and quantum mechanics. Here's a summary and exploration of the key ideas. 1. Time travel and general relativity. Gödel's rotating universe. In 1949, mathematician Kurt Gödel discovered a solution to Einstein's equations of general relativity that described a rotating universe. In this model, time travel to the past becomes possible because the rotation of the universe creates closed time-like curves, CTCs. These are paths in space-time that loop back on themselves, allowing an object or person to return to an earlier point in time. However, observations show that our universe is not rotating, so the solution doesn't apply to reality. Other space-time solutions, other solutions to Einstein's equations, such as rotating black holes or cosmic strings, hypothetical ultra-dense structures, also allow for CTCs. These scenarios involve extreme warping of space-time, but they remain speculative and lack empirical evidence. 1. Wormholes and faster-than-light travel. Wormholes. A wormhole is a theoretical tunnel through space-time that connects two distant points. If traversable wormholes exist, they could allow rapid travel between distant locations or even travel back in time. However, creating or sustaining a wormhole would require exotic matter with negative energy density, which is not known to exist in sufficient quantities. Faster-than-light travel. According to relativity, traveling faster than light, FTL, would effectively allow time travel to the past. This is illustrated by the twin paradox and the limerick about the young lady of white. However, FTL travel is prohibited by the laws of physics as we currently understand them, because it would require infinite energy and lead to causal paradoxes. 1. Quantum mechanics and time travel, negative energy, and the Casimir effect. Quantum mechanics allows for regions of negative energy density, as demonstrated by the Casimir effect. This phenomenon occurs when two parallel metal plates placed close together create a vacuum energy difference, resulting in a measurable force. While this shows that space-time can be warped in ways that might permit time travel, the energy scales involved are far too small for practical applications. Virtual particles and closed time-like curves. Quantum theory also allows for microscopic time travel through the behavior of virtual particles. For example, a particle-antiparticle pair can be interpreted as a single particle moving forward and backward in time. This idea is central to the explanation of Hawking radiation from black holes. 1. Paradoxes of time travel, the grandfather paradox. If time travel to the past were possible, one could theoretically change events in ways that create logical contradictions, such as preventing one's own existence. This paradox highlights the potential inconsistencies introduced by time travel. Consistent histories versus alternative histories, consistent histories. This approach suggests that any time travel must be consistent with the existing timeline. In other words, you cannot change the past in a way that contradicts the present. This implies a lack of free will for time travelers. Alternative histories. This hypothesis proposes that time travelers enter alternate timelines, allowing them to change events without affecting their original history. This idea is popular in science fiction, such as the Back to the Future movies. 1. The chronology protection conjecture proposed by Stephen Hawking. This conjecture suggests that the laws of physics prevent macroscopic time travel to avoid paradoxes. One possible mechanism is the buildup of infinite energy densities when space-time is warped to create CTCs, which would destabilize the timeline. While not proven, this idea offers a plausible explanation for why we don't observe time travelers from the future. 2. Why haven't we met time travelers? If time travel were possible, why haven't we encountered visitors from the future? Possible explanations include time travel is confined to the future, not the past. Time travelers are discrete or avoid altering history. The chronology protection conjecture prevents time travel on macroscopic scales. Conclusion. Time travel remains a tantalizing possibility within the framework of theoretical physics, but it is fraught with challenges and paradoxes. While solutions like wormholes and rotating universes offer intriguing pathways, they require conditions that are either speculative or impossible with our current understanding of the universe. Quantum mechanics allows for microscopic time travel, but scaling this up to human-sized objects seems unlikely. Ultimately, the absence of time travelers and the potential for paradoxes suggest that time travel to the past may remain in the realm of science fiction. However, as our understanding of physics evolves, so too might our ability to explore these fascinating ideas. Continue certainly. Let's delve deeper into some of the unresolved questions, implications, and philosophical considerations surrounding time travel, as well as the ongoing scientific efforts to explore these ideas. 1. Philosophical implications of time travel. Time travel isn't just a scientific curiosity. It raises profound philosophical questions about free will, causality, and the nature of reality. Free will versus determinism. If time travel to the past is possible, does it imply that our actions are predetermined? The consistent histories approach suggests that any actions taken by a time traveler would have already been part of the historical record, effectively negating free will. This aligns with a deterministic view of the universe, where every event is causally determined by prior events. The nature of reality. The alternative histories hypothesis introduces the idea of multiple timelines or parallel universes. This aligns with the many worlds interpretation of quantum mechanics, where every possible outcome of an event occurs in a separate universe. If time travel involves branching timelines, it raises questions about the nature of identity and continuity across these realities. 1. Scientific efforts to explore time travel. While time travel remains speculative, scientists continue to explore related concepts through theoretical and experimental work. Wormholes and exotic matter. Researchers are investigating whether exotic matter with negative energy density could exist in sufficient quantities to stabilize a wormhole. While the Casimir effect demonstrates the existence of negative energy on a tiny scale, scaling this up to macroscopic levels remains a significant challenge. Quantum time travel. Quantum mechanics allows for microscopic time travel through phenomena like particle-antiparticle interactions. Some scientists are exploring whether these effects could be harnessed or observed in controlled experiments, though this remains highly theoretical. Simulating time travel. In 2020, researchers used quantum computers to simulate time-reversed processes, effectively reversing time for a single particle. While this doesn't constitute actual time travel, it provides insights into how quantum systems might behave under time-reversed conditions. Time travel in popular culture. Time travel has long been a staple of science fiction, reflecting humanity's fascination with the idea of revisiting the past or exploring the future. Stories like H.G. Wells' The Time Machine, the Back to the Future trilogy, and Doctor Who explore the possibilities and consequences of time travel, often highlighting the paradoxes and ethical dilemmas it entails. The butterfly effect. Many stories emphasize the idea that even small changes in the past can have drastic, unpredictable consequences in the future. This concept, popularized by chaos theory, underscores the potential dangers of tampering with history. Ethical considerations. If time travel were possible, who would have the right to use it? Would it be used for personal gain, scientific exploration, or to correct historical injustices? These questions highlight the moral complexities of time travel. 1. The future of time travel research. While time travel remains speculative, ongoing advancements in physics and technology keep the dream alive. Unified theory of physics. A complete theory that unifies general relativity, which governs the large-scale structure of space-time, with quantum mechanics, which governs the behavior of particles, could provide new insights into the feasibility of time travel. String theory and loop quantum gravity are among the leading candidates for such a theory. Experimental tests. As technology advances, scientists may be able to test some of the predictions of general relativity and quantum mechanics more rigorously. For example, detecting cosmic strings or observing the effects of negative energy in laboratory settings could provide indirect evidence for mechanisms that might enable time travel. Chronology protection. If the chronology protection conjecture holds, it would effectively prevent time travel on macroscopic scales. Proving or disproving this conjecture remains a key challenge for physicists. 1. The role of imagination in science. Time travel serves as a reminder of the importance of imagination in scientific discovery. Many ideas that once seemed purely speculative, such as black holes, gravitational waves, and quantum entanglement, have since been confirmed through observation and experimentation. While time travel may seem far-fetched today, it's possible that future breakthroughs could transform our understanding of space-time and make the impossible possible. 2. Final thoughts. Time travel captivates our imagination because it challenges our understanding of time, causality, and the universe itself. While the scientific consensus suggests that macroscopic time travel is unlikely, the exploration of these ideas continues to push the boundaries of human knowledge. Whether through the lens of physics, philosophy, or fiction, time travel invites us to question what we know and imagine what might be possible. As Stephen Hawking once quipped, the best evidence we have that time travel is not possible and never will be is that we have not been invaded by hordes of tourists from the future. Yet the pursuit of this dream reminds us that science is not just about answering questions, it's about asking the right ones and daring to explore the unknown. Continue, absolutely. Let's continue exploring the fascinating implications, challenges, and future directions of time travel research, as well as its broader cultural and scientific significance. 1. The role of black holes in time travel. Black holes, some of the most mysterious objects in the universe, play a central role in discussions about time travel. Their extreme gravitational fields warp space-time in ways that could, in theory, allow for time travel. Rotating black holes, Kerr black holes, unlike non-rotating black holes, Schwarzschild black holes, rotating black holes, have a region called the ergosphere, where space-time is dragged along with the rotation. Some solutions to Einstein's equations suggest that passing through the ergosphere could allow for travel into the past. However, the intense tidal forces and radiation near black holes make this an impractical and deadly proposition for any potential time traveler. Singularities and closed time-like curves. At the center of a black hole lies a singularity, a point where the laws of physics as we know them break down. Some theoretical models suggest that singularities could act as gateways to other regions of space-time or even other universes. However, the extreme conditions and lack of a complete theory of quantum gravity make this idea highly speculative. 1. The multiverse and time travel. The concept of the multiverse, a collection of parallel universes, offers a potential resolution to some of the paradoxes associated with time travel. Branching timelines. In the many worlds interpretation of quantum mechanics, every decision or event creates a branching of timelines. If time travel were possible, it might involve moving between these parallel universes rather than altering a single fixed timeline. This would avoid paradoxes like the grandfather paradox, as changes made in the past would create a new timeline rather than overwriting the original one. Multiverse as a safety valve. The multiverse could act as a safety valve for time travel, allowing changes to the past without disrupting the original timeline. This idea is popular in science fiction, such as in the Avengers Endgame movie, where characters travel to alternate timelines to retrieve resources without affecting their own reality. 1. Time travel and the arrow of time. One of the most profound mysteries in physics is the arrow of time, the fact that time appears to flow in one direction, from past to future. Time travel challenges this notion by suggesting that the arrow of time might not be absolute. Entropy and the second law of thermodynamics. The increase of entropy disorder in the universe is often cited as the reason time flows forward. However, in a closed system or a universe with specific boundary conditions, entropy might decrease, potentially allowing for time-reversed processes. This raises the question of whether time travel could involve regions of space-time where entropy decreases, effectively reversing the arrow of time. CPT symmetry in particle physics, the combination of charge conjugation, C, parity, P, and time reversal, T, is believed to be a fundamental symmetry of the universe. This means that the laws of physics are invariant under a reversal of time, charge, and spatial coordinates. While this symmetry holds at the microscopic level, it's unclear how it might apply to macroscopic time travel. 1. Ethical and societal implications of time travel. If time travel were ever possible, it would raise profound ethical and societal questions. Changing history. Would it be ethical to change historical events, even if it were possible? For example, preventing a war or saving lives might seem noble, but the unintended consequences could be catastrophic. This dilemma is a common theme in time travel stories, such as The Butterfly Effect and November 22, 63 by Stephen King. Temporal tourism. If time travel became a reality, who would have access to it? Would it be restricted to governments, scientists, or the wealthy? The potential for abuse, such as altering history for personal gain or exploiting past societies, raises significant ethical concerns. Temporal pollution. Introducing advanced technology or knowledge to past societies could disrupt their development, leading to unintended consequences. This concept, sometimes called temporal pollution, highlights the need for strict regulations if time travel were ever achieved. 1. The search for extraterrestrial time travelers. If time travel is possible, why haven't we encountered travelers from the future? This question, often referred to as the Fermi paradox of time travel, has several possible explanations. Temporal prime directive. Future civilizations might adhere to a policy of non-interference, similar to the prime directive in Star Trek, to avoid disrupting the past. Alternate timelines. Time travelers might exist in alternate timelines, making their presence undetectable in our own. Technological limitations. Time travel might be so energy-intensive or technologically challenging that it's rarely attempted even by advanced civilizations. 1. The future of time travel. Research. While time travel remains speculative, ongoing research in physics and cosmology continues to explore the boundaries of what's possible. Quantum gravity. A theory of quantum gravity, which unites general relativity and quantum mechanics, could provide new insights into the nature of space-time and the feasibility of time travel. Candidates like string theory and loop quantum gravity are actively being studied. Advanced simulations. As computational power increases, scientists may be able to simulate space-time under extreme conditions, providing new insights into the behavior of wormholes, closed time-like curves, and other time travel mechanisms. Observational evidence. While direct evidence of time travel is lacking, indirect evidence, such as the detection of cosmic strings or exotic matter, could provide clues about the mechanisms that might make time travel possible. 1. The cultural impact of time travel. Time travel has had a profound impact on culture, inspiring countless works of literature, film, and art. It serves as a metaphor for humanity's desire to understand the past, shape the future, and explore the unknown. Literature. From H.G. Wells' The Time Machine to Octavia Butler's Kindred, time travel stories explore themes of history, identity, and the human condition. Film and television, movies like Back to the Future, Interstellar and Looper, as well as TV shows like Doctor Who and Dark, use time travel to explore complex narratives and philosophical questions. Art and philosophy. Time travel challenges our understanding of reality, inspiring artists and philosophers to question the nature of time, memory, and existence. 1. Conclusion. The enduring allure of time. Time travel captivates us because it represents the ultimate frontier, a way to transcend the limitations of our existence and explore the mysteries of the universe. While the scientific challenges are immense, the pursuit of this dream drives innovation, creativity, and discovery. As we continue to explore the cosmos and unravel the laws of physics, we may one day find answers to the questions that time travel raises. Until then, it remains a powerful symbol of humanity's boundless curiosity and imagination. Whether through science, fiction, or philosophy, the journey through time reminds us that the universe is far stranger and more wonderful than we can imagine. Continue, certainly. Let's delve even deeper into the scientific, philosophical, and cultural dimensions of time travel, exploring its implications for our understanding of reality and its potential to reshape the future of humanity. 1. Time travel and the nature of reality. Time travel challenges our fundamental understanding of reality, forcing us to reconsider concepts like causality, determinism, and the flow of time. Causality and paradoxes. The idea of traveling back in time and altering events introduces paradoxes, such as the grandfather paradox, where a time traveler prevents their own existence. These paradoxes suggest that our intuitive understanding of cause and effect might not hold in a universe where time travel is possible. Block universe theory. Some physicists propose that time is an illusion and the past, present, and future all exist simultaneously in a block universe. In this view, time travel wouldn't involve changing the past, but rather moving between different points in a fixed four-dimensional space-time. This idea aligns with the consistent histories approach where time travel is possible only if it doesn't create contradictions. Retrocausality. In quantum mechanics, retrocausality suggests that future events can influence past events. While this doesn't imply macroscopic time travel, it challenges the traditional arrow of time and opens the door to new ways of thinking about causality. 1. Time travel and the search for extraterrestrial intelligence, CRT. If advanced civilizations exist elsewhere in the universe, they might have mastered time travel. This raises intriguing questions for the search for extraterrestrial intelligence, SETI. Temporal messaging. Could extraterrestrial civilizations send messages backward in time to communicate with us? While this idea is speculative, it suggests new avenues for SETI research, such as looking for anomalous signals that might indicate a temporal origin. Artifacts from the future. If time travel is possible, advanced civilizations might leave behind temporal artifacts, objects or structures that appear out of place in their historical context. These could serve as evidence of their existence and technological prowess. 1. Time travel and human evolution. The ability to travel through time could have profound implications for the future of humanity, both biologically and culturally. Genetic engineering and evolution. If humans gain the ability to travel through time, they might use it to influence their own evolution, either by introducing genetic modifications or by selecting specific traits in future generations. Cultural evolution. Time travel could accelerate cultural and technological development by allowing future knowledge to be shared with the past. However, this could also lead to cultural homogenization or the loss of historical diversity. 1. Time travel and the philosophy of identity. Time travel raises deep questions about personal identity and continuity, the ship of Theseus. Paradox: if a time traveler undergoes significant changes during their journey, are they still the same person when they return? This question echoes the ancient philosophical paradox of the ship of Theseus, which explores whether an object that has had all its components replaced remains fundamentally the same. Multiple selves. In scenarios involving branching timelines or parallel universes, a time traveler might encounter alternate versions of themselves. This raises questions about the nature of identity and whether these alternate selves are truly you. 1. Time travel and the limits of human knowledge. Time travel challenges the limits of human knowledge and our ability to understand the universe, the unknowable past and future. Even if time travel were possible, Accessing the past or future might not provide complete knowledge. Historical records could be incomplete or biased, and the future might be inherently uncertain due to the probabilistic nature of quantum mechanics. The role of observation. In quantum mechanics, the act of observation affects the system being observed. If time travel involves observing or interacting with the past, it could alter the very events being studied, creating a feedback loop that complicates our understanding. 1. Time travel and the future of science. The pursuit of time travel drives scientific innovation and collaboration across disciplines, interdisciplinary research. Time travel research requires collaboration between physicists, mathematicians, philosophers, and even computer scientists. This interdisciplinary approach fosters creativity and leads to breakthroughs in multiple fields. Technological spin-offs. While time travel itself may remain elusive, the technologies developed in its pursuit, such as advanced propulsion systems, quantum computers, and space-time sensors, could have transformative applications in other areas of science and industry. 1. Time travel and the human imagination. Time travel continues to inspire the human imagination, serving as a powerful tool for exploring what-if scenarios. Speculative fiction. Time travel stories allow us to explore alternate histories, dystopian futures, and utopian possibilities. They challenge us to think critically about the consequences of our actions and the direction of society. Creative problem solving, the imaginative exercise of designing time machines or navigating temporal paradoxes, fosters creative problem solving skills that can be applied to real-world challenges. 1. The ultimate question: should we time travel? Even if time travel becomes possible, humanity will face the profound question of whether we should use it. The risks of hubris. Time travel represents the ultimate expression of human ambition and curiosity. However, it also carries the risk of hubris, the belief that we can control or manipulate time without unintended consequences. A tool for good or evil. Like any powerful technology, time travel could be used for both beneficial and harmful purposes. Establishing ethical guidelines and safeguards would be essential to prevent misuse. 1. The legacy of time travel. Time travel is more than a scientific concept. It's a cultural and philosophical legacy that reflects humanity's deepest aspirations and fears. A symbol of hope. Time travel represents the hope that we can learn from the past, shape the future, and overcome the limitations of our existence. A reminder of our limits. At the same time, time travel reminds us of the boundaries of human knowledge and the mysteries that remain unsolved. 1. Final reflections. Time travel is a concept that transcends science, touching on the very essence of what it means to be human. It challenges us to question our assumptions, push the boundaries of knowledge, and imagine new possibilities. While the scientific challenges are immense, the journey of exploration is itself a form of time travel, a voyage through the landscape of human thought and creativity. As we continue to explore the universe and unravel its mysteries, the dream of time travel will remain a beacon, guiding us toward a deeper understanding of ourselves and the cosmos. Whether or not we ever achieve the ability to travel through time, the pursuit of this dream enriches our lives and expands the horizons of human potential. Continue certainly. Let's continue to explore the multifaceted nature of time travel, diving deeper into its scientific, philosophical, and cultural implications, as well as its potential to reshape our understanding of existence itself. 1. Time travel and the philosophy of time. Time travel forces us to confront fundamental questions about the nature of time itself. Is time a fixed linear progression, or is it more fluid and malleable? Presentism versus eternalism. Presentism is the view that only the present moment is real, while the past and future are not. Eternalism, on the other hand, posits that past, present, and future all exist equally, much like different points in space. Time travel aligns more closely with eternalism, as it suggests that all moments in time are equally real and accessible. The flow of time. Our subjective experience of time as flowing from past to future might be an illusion. If time travel were possible, it would challenge this perception, suggesting that time is more like a dimension through which we can move rather than a river carrying us forward. 1. Time travel and the multiverse. The concept of the multiverse, a collection of parallel universes, offers a potential framework for understanding time travel without paradoxes, branching timelines, In the many worlds interpretation of quantum mechanics, every decision or event creates a branching of timelines. Time travel could involve moving between these parallel universes, allowing changes to the past without affecting the traveler's original timeline. This idea is popular in science fiction such as in the Back to the Future trilogy and Avengers, Endgame, Infinite Possibilities. If the multiverse is infinite, then every possible outcome of every event exists in some universe. Time travel could allow access to these infinite possibilities, offering a way to explore alternate histories and futures. 1. Time travel and the search for meaning. Time travel raises profound questions about the nature of existence and the search for meaning, the illusion of free will. If time travel is possible and the universe operates on deterministic principles, does free will exist, or are our actions predetermined, with time travelers merely fulfilling their role in a fixed timeline? The quest for immortality. Time travel could offer a form of immortality, allowing individuals to live across different eras or even escape death by traveling to a time when medical technology can save them. This raises ethical questions about the distribution of such technology and its impact on society. 1. Time travel and the future of humanity. The ability to travel through time could have transformative implications for the future of humanity. Colonization of the past and future. Time travel could enable the colonization of different eras, allowing humanity to spread across time as well as space. This could provide new opportunities for resource acquisition and cultural exchange. Temporal diplomacy. If multiple civilizations gain the ability to time travel, it could lead to complex diplomatic relations across time. Establishing treaties and agreements to prevent temporal interference would be essential to maintain stability. 1. Time travel and the limits of science. Time travel challenges the limits of scientific inquiry and our ability to understand the universe, the unknowable past and future. Even if time travel were possible, accessing the past or future might not provide complete knowledge. Historical records could be incomplete or biased, and the future might be inherently uncertain due to the probabilistic nature of quantum mechanics. The role of observation. In quantum mechanics, the act of observation affects the system being observed. If time travel involves observing or interacting with the past, it could alter the very events being studied, creating a feedback loop that complicates our understanding. 1. Time travel and the future of science. The pursuit of time travel drives scientific innovation and collaboration across disciplines. Interdisciplinary research. Time travel research requires collaboration between physicists, mathematicians, philosophers, and even computer scientists. This interdisciplinary approach fosters creativity and leads to breakthroughs in multiple fields. Technological spin-offs. While time travel itself may remain elusive, the technologies developed in its pursuit, such as advanced propulsion systems, quantum computers, and space-time sensors, could have transformative applications in other areas of science and industry. 1. Time travel and the human imagination. Time travel continues to inspire the human imagination, serving as a powerful tool for exploring what-if scenarios. Speculative fiction. Time travel stories allow us to explore alternate histories, dystopian futures, and utopian possibilities. They challenge us to think critically about the consequences of our actions and the direction of society. Creative problem solving. The imaginative exercise of designing time machines or navigating temporal paradoxes fosters creative problem-solving skills that can be applied to real-world challenges. 1. The ultimate question: should we time travel? Even if time travel becomes possible, humanity will face the profound question of whether we should use it. The risks of hubris. Time travel represents the ultimate expression of human ambition and curiosity. However, it also carries the risk of hubris, the belief that we can control or manipulate time without unintended consequences, a tool for good or evil. Like any powerful technology, time travel could be used for both beneficial and harmful purposes. Establishing ethical guidelines and safeguards would be essential to prevent misuse. 1. The legacy of time travel. Time travel is more than a scientific concept. It's a cultural and philosophical legacy that reflects humanity's deepest aspirations and fears. A symbol of hope. Time travel represents the hope that we can learn from the past, shape the future, and overcome the limitations of our existence. A reminder of our limits. At the same time, time travel reminds us of the boundaries of human knowledge and the mysteries that remain unsolved. 1. Final reflections. Time travel is a concept that transcends science, touching on the very essence of what it means to be human. It challenges us to question our assumptions, push the boundaries of knowledge, and imagine new possibilities. While the scientific challenges are immense, the journey of exploration is itself a form of time travel, a voyage through the landscape of human thought and creativity. As we continue to explore the universe and unravel its mysteries, the dream of time travel will remain a beacon, guiding us toward a deeper understanding of ourselves and the cosmos. Whether or not we ever achieve the ability to travel through time, the pursuit of this dream enriches our lives and expands the horizons of human potential. 1. The enduring mystery of time. Time travel remains one of the most captivating and elusive ideas in science and philosophy. It challenges us to rethink our understanding of reality, pushes the boundaries of human knowledge, and inspires us to imagine a future where the impossible becomes possible. While the journey toward understanding time travel is far from over, it is a journey worth taking, one that reminds us of the boundless potential of the human spirit. Conclusion. The timeless allure of time travel captivates us because it represents the ultimate frontier, a way to transcend the limitations of our existence and explore the mysteries of the universe. It bridges the gap between science and imagination, challenging us to rethink our understanding of reality, causality, and the very nature of time itself. While the scientific feasibility of time travel remains uncertain, the pursuit of this dream has led to profound insights into physics, philosophy, and the human condition. From the rotating universes of Gödel to the wormholes of Einstein and Rosen, from the quantum realms of virtual particles to the speculative multiverse, time travel pushes the boundaries of what we know and what we dare to imagine. It raises questions about free will, identity, and the ethical implications of altering the past or shaping the future. It inspires us to dream of a future where the impossible becomes possible, where humanity can learn from its mistakes, explore new horizons, and perhaps even escape the confines of mortality. Yet time travel also serves as a reminder of our limitations. The paradoxes it introduces, such as the grandfather paradox and the butterfly effect, highlight the delicate balance of cause and effect that underpins our universe. The absence of time travelers from the future, as Stephen Hawking famously noted, suggests that the laws of physics may conspire to prevent such journeys, protecting the integrity of space-time and the arrow of time. Ultimately, time travel is more than a scientific concept or a plot device for science fiction. It is a symbol of humanity's boundless curiosity, creativity, and ambition. It challenges us to question, to explore, and to dream. Whether or not we ever achieve the ability to travel through time, the journey of discovery enriches our lives and expands the horizons of human potential. As we continue to unravel the mysteries of the cosmos, the dream of time travel will remain a beacon, guiding us toward a deeper understanding of ourselves and the universe. It reminds us that the pursuit of knowledge is not just about finding answers, it's about asking the right questions and daring to imagine the impossible. In the end, time travel is not just about moving through time, it's about transcending the limits of our imagination and embracing the infinite possibilities of existence. And so the story of time travel continues, a timeless tale of curiosity, wonder, and the enduring human spirit. Continue 1. Time travel as a metaphor for human progress. Time travel is not just a scientific or philosophical concept. It is also a powerful metaphor for human progress and the relentless pursuit of knowledge. It symbolizes our desire to learn from the past, shape the future, and overcome the limitations of our present circumstances. Learning from the past. Just as time travel allows us to revisit historical events, the study of history enables us to learn from the successes and failures of previous generations. This knowledge can guide us in making better decisions and building a brighter future. Shaping the future. Time travel represents our aspiration to influence the future, whether through technological innovation, social change, or personal growth. It reminds us that our actions today have the power to shape the world of tomorrow. Overcoming limitations. The dream of time travel embodies our desire to transcend the boundaries of our existence, whether they are physical, temporal, or intellectual. It inspires us to push the limits of what is possible and strive for greatness. 1. Time travel and the human condition. Time travel touches on some of the most profound aspects of the human condition, including our relationship with time, memory, and mortality. Our relationship with time. Time is one of the most fundamental aspects of our existence, yet it is also one of the most elusive. Time travel challenges us to rethink our relationship with time, encouraging us to see it not as a linear progression, but as a multi-dimensional landscape full of possibilities. Memory and identity. Our memories shape our sense of identity and continuity. Time travel raises questions about how our memories would be affected by journeys through time and whether we would remain the same person after experiencing different eras. Mortality and immortality. Time travel offers a tantalizing glimpse of immortality, allowing us to imagine escaping the inevitability of death. However, it also reminds us of the preciousness of our finite existence and the importance of making the most of the time we have. 1. Time travel and the future of exploration. The pursuit of time travel drives us to explore new frontiers, both in science and in our understanding of the universe, exploring the cosmos. The technologies and theories developed in the quest for time travel could revolutionize our ability to explore the cosmos. From advanced propulsion systems to new insights into the nature of space-time, the pursuit of time travel could open up new possibilities for interstellar and intergalactic travel. Exploring the mind. Time travel also invites us to explore the frontiers of the human mind, challenging us to think creatively, critically, and imaginatively. It encourages us to question our assumptions and expand our horizons. 1. Time travel and the power of imagination. Time travel is a testament to the power of human imagination. It shows us that the boundaries of reality are not fixed but can be pushed and redefined through creativity and innovation. Inspiring creativity. Time travel stories have inspired countless works of literature, film, and art, enriching our culture and expanding our imagination. They challenge us to think beyond the confines of our everyday experience and envision new possibilities. Fostering innovation. The pursuit of time travel drives scientific and technological innovation, leading to breakthroughs that can transform our world. It reminds us that the impossible can become possible through the power of human ingenuity. 1. The ethical imperative of time travel. If time travel were ever achieved, it would come with profound ethical responsibilities. We would need to consider the implications of our actions on the past, present, and future, and ensure that the power of time travel is used for the greater good. Preserving history. Altering the past could have unforeseen consequences, erasing important lessons and disrupting the course of history. We would need to establish guidelines to protect the integrity of the timeline, shaping the future. Time travel could offer unprecedented opportunities to shape the future, but it also carries the risk of misuse. We would need to ensure that this power is used responsibly and equitably. Respecting life. Time travel raises questions about the value of life across different eras. We would need to consider the ethical implications of interacting with past and future civilizations and ensure that we respect their autonomy and dignity. 1. The enduring legacy of time travel. Time travel is more than a scientific concept or a plot device for science fiction. It is a symbol of humanity's boundless curiosity, creativity, and ambition. It challenges us to question, to explore, and to dream. Whether or not we ever achieve the ability to travel through time, the journey of discovery enriches our lives and expands the horizons of human potential. As we continue to unravel the mysteries of the cosmos, the dream of time travel will remain a beacon guiding us toward a deeper understanding of ourselves and the universe. It reminds us that the pursuit of knowledge is not just about finding answers, it's about asking the right questions and daring to imagine the impossible. In the end, time travel is not just about moving through time, it's about transcending the limits of our imagination and embracing the infinite possibilities of existence. 1. Final thoughts, the timeless journey. Time travel is a journey through the landscape of human thought, creativity, and aspiration. It is a journey that transcends the boundaries of science and philosophy, touching on the very essence of what it means to be human. While the scientific challenges are immense, the pursuit of this dream enriches our lives and expands the horizons of human potential. As we continue to explore the universe and unravel its mysteries, the dream of time travel will remain a beacon, guiding us towards a deeper understanding of ourselves and the cosmos. Whether or not we ever achieve the ability to travel through time, the journey of discovery is itself a form of time travel, a voyage through the landscape of human thought and creativity. And so the story of time travel continues, a timeless tale of curiosity, wonder, and the enduring human spirit. It is a story that reminds us of the boundless potential of the human imagination and the infinite possibilities of existence. In the end, time travel is not just about moving through time, it's about transcending the limits of our imagination and embracing the infinite possibilities of existence. Time travel in Quran. Found 23 results. The concept of time travel in the Quran is a fascinating topic that intertwines Islamic theology, cosmology, and modern scientific theories. While the Quran does not explicitly mention time travel as understood in contemporary science, it contains verses and narratives that hint at the relativity of time and extraordinary events that align with the idea of temporal manipulation. Below is a detailed exploration of this topic. 1. Relativity of time in the Quran. The Quran introduces the concept of time as relative, a notion that aligns with modern physics, particularly Einstein's theory of relativity. Several verses highlight how time can vary depending on the observer's frame of reference or the realm they inhabit. Quran 22:47, "A day with your Lord is like 1,000 years of what you count." This verse suggests that time in the divine realm operates differently from earthly time. 178, Quran 74. "The angels and the Spirit ascend to him in a day, the measure of which is 50,000 years." This indicates that celestial beings experience time at a vastly different rate compared to humans. 67, Quran 32:5. "He arranges each matter from the heaven to the earth, then it will ascend to him in a day, the extent of which is 1,000 years of those which you count." This further emphasizes the relativity of time. 8. These verses suggest that time is not absolute but varies depending on the context, a concept that resonates with modern scientific understanding. 1. Miraculous events and time manipulation. The Quran recounts several stories that can be interpreted as instances of time manipulation or time dilation. The people of the cave, Surah Al-Kahf. A group of believers slept in a cave for 309 years, yet they perceived their slumber as only a day or part of a day. This story illustrates how time can pass differently for individuals in extraordinary circumstances. 712. The story of Uzair, Ezra. In Surah Al-Baqarah 2:259, a man is resurrected after being dead for 100 years, yet he perceives his death as lasting only a day or part of a day. This narrative underscores the Quranic theme of time as a flexible and relative concept. 78. The Night Journey, Isra and Miraj. Prophet Muhammad's miraculous journey from Mecca to Jerusalem and then to the heavens is often interpreted as a form of time travel. The Prophet experienced events that transcended ordinary temporal boundaries, such as meeting other prophets and witnessing future occurrences. 612. 1. Scientific insights and Quranic verses. The Quran's descriptions of time relativity predate modern scientific discoveries by over a millennium. For example, time dilation, the Quranic verses about time differences between earthly and celestial realms align with Einstein's theory of relativity, which states that time slows down in stronger gravitational fields or at higher velocities. 812. Wormholes and cosmic travel. Some interpretations suggest that the Quran hints at phenomena like wormholes or cosmic shortcuts, which could theoretically enable time travel. For instance, the story of Dhul-Qarnayn in Surah Al-Kahf mentions him traveling vast distances in seemingly short periods, which some scholars link to advanced knowledge of space-time. 12. 1. Theological perspectives on time travel. Islamic scholars have debated the possibility of time travel, often concluding that while it is theoretically possible within the realm of divine power, it is beyond human capability. Key points include divine knowledge. The Quran emphasizes that Allah alone knows the unseen, including the future. This suggests that any form of time travel would require divine intervention and cannot be achieved through human means alone. 15. Free will and predestination. Time travel, especially to the past, raises questions about free will and predestination. Islamic theology maintains that Allah's knowledge encompasses all events, and altering the past would contradict divine wisdom. 911. 1. Symbolic and philosophical implications. The Quran's references to time serve as metaphors for deeper spiritual truths, temporal limitations, time is a creation of Allah, and humans are bound by it in this world. However, in the afterlife, time will cease to have the same meaning, as eternal life in paradise or hell transcends earthly temporal constraints. 57. Reflection on mortality. The Quran encourages believers to reflect on the fleeting nature of time and to use it wisely in preparation for the hereafter. 57. Conclusion. The Quran does not explicitly describe time travel as a scientific concept, but offers profound insights into the relativity of time and extraordinary events that challenge conventional temporal boundaries. These narratives align with modern scientific theories, while also serving as reminders of Allah's omnipotence and the limitations of human understanding. Whether viewed through a theological or scientific lens, the Quran's treatment of time remains a source of inspiration and contemplation for believers and scholars alike. For further reading, you can explore the reference sources such as Islam Web and The Last Dialogue. Continue. Certainly. Let's delve deeper into the topic of time travel in the Quran by exploring additional perspectives, interpretations, and connections to both Islamic theology and modern science. This continuation will also address some of the philosophical and spiritual dimensions of time as presented in the Quran. 1. The Quranic concept of time and creation. The Quran frequently emphasizes the transient nature of time and the finite existence of the universe, contrasting it with the eternal nature of Allah. This duality between the temporal and the eternal is central to Islamic cosmology. Temporal creation. The Quran describes the creation of the universe as a process that occurred over a period of time, often referred to as 6 days, for example, Quran 7:54. However, these days are not necessarily equivalent to earthly days, but may represent epochs or phases of creation, aligning with modern cosmological theories like the Big Bang. Eternity and the hereafter. The Quran contrasts the temporal nature of this world with the timelessness of the afterlife. In paradise, Jannah, and hell, Jahannam, time as we know it ceases to exist. This concept is reflected in verses like Quran 14:48. On the day the earth will be replaced by another earth, and the heavens as well, and all creatures will come out before Allah, the One, the Prevailing. 1. The story of Dhul Qarnayn and cosmic travel. The story of Dhul Qarnayn in Surah Al-Kahf 1883-101 is often interpreted as a narrative that hints at advanced knowledge of space-time and cosmic travel. Dhul Qarnayn is described as a righteous ruler who traveled to the ends of the earth, encountering extraordinary phenomena. The barrier of Gog and Magog. Dhul Qarnayn built a barrier to contain the corrupt tribes of Gog and Magog. Some modern interpretations suggest that this barrier could symbolize a cosmic or temporal boundary, hinting at advanced knowledge of space-time manipulation. Cosmic journeys. Dhul Qarnayn's travels to the setting of the sun and the rising of the sun are often interpreted metaphorically, but some scholars suggest they could represent journeys through space-time or even dimensions beyond human comprehension. 1. The Quran and modern scientific theories. The Quran's descriptions of time and creation have inspired comparisons to modern scientific theories such as relativity, quantum mechanics, and cosmology. While these comparisons are speculative, they highlight the Quran's ability to resonate with contemporary scientific thought. Big Bang Theory. The Quran describes the universe as originating from a single point, Quran 21:30. Do the disbelievers not realize that the heavens and earth were once one mass, then we split them apart? Which aligns with this Big Bang Theory. Expanding universe, Quran 51:47 states, "We built the universe with great might, and we are certainly expanding it." This verse is often cited as evidence of the Quran's anticipation of the expanding universe theory. Black holes and wormholes. Some interpretations suggest that the Quran's descriptions of cosmic phenomena such as the smoke, dukhan, from which the heavens were created, Quran 41:11, could hint at black holes or wormholes, which are theorized to warp space-time. 1. Philosophical implications of time in the Quran. The Quran's treatment of time invites reflection on the nature of existence, human purpose, and the divine plan, temporal versus eternal. The Quran contrasts the fleeting nature of worldly life with the eternal nature of the afterlife. This duality encourages believers to focus on spiritual growth and preparation for the hereafter, rather than becoming overly attached to temporal pursuits. Divine decree, qadr. The Quran emphasizes that all events are part of Allah's divine decree, which encompasses past, present, and future. This concept aligns with the idea of a block universe in physics, where all moments in time exist simultaneously from a divine perspective. Human responsibility. While time is a creation of Allah, humans are responsible for how they use it. Verses like Quran 103:1-3. By time, indeed, mankind is in loss, except for those who have believed and done righteous deeds. Underscore the importance of using time wisely. 1. Time travel in Islamic eschatology. Islamic eschatology, the study of the end times, contains elements that can be interpreted as involving time travel or temporal manipulation. The return of Prophet Isa, Jesus. Islamic tradition holds that Prophet Isa will return to earth before the Day of Judgment. His return is often described as a miraculous event that transcends ordinary temporal boundaries. The Mahdi, the coming of the Mahdi, a guided leader who will establish justice before the end times, is another eschatological event that involves extraordinary circumstances, potentially including temporal anomalies. 1. Spiritual time travel, a metaphor for inner transformation. Beyond the physical time travel, the Quran also offers a metaphorical understanding of time travel as a journey of spiritual transformation, repentance and renewal. The Quran encourages believers to travel back in time through repentance, seeking forgiveness for past sins and renewing their commitment to Allah. This spiritual journey allows individuals to rewrite their personal histories and align themselves with divine guidance. The journey of the soul. The Quran describes the soul's journey through life, death, and the afterlife as a form of temporal progression. This journey culminates in the eternal realm, where time as we know it ceases to exist. 1. Conclusion. Time travel as a divine mystery. The Quran does not explicitly describe time travel as a scientific concept, but it offers profound insights into the nature of time, the relativity of temporal experience, and the extraordinary events that challenge conventional understanding. These narratives align with modern scientific theories while also serving as reminders of Allah's omnipotence and the limitations of human knowledge. Whether viewed through a theological, scientific, or philosophical lens, the Quran's treatment of time invites believers to reflect on the mysteries of existence, the transient nature of worldly life, and the eternal reality of the hereafter. Time travel in this context becomes not just a scientific possibility, but a spiritual metaphor for humanity's journey toward divine understanding and eternal fulfillment. For further exploration, you can refer to Islamic scholarly works Tafsir, exegesis of the Quran, and contemporary discussions on the intersection of science and religion. The Quran remains a timeless source of guidance, inviting humanity to ponder the mysteries of time and existence. Certainly. Let's continue to explore the concept of time travel in the Quran by delving into additional narratives, theological implications, and connections to modern scientific thought. This continuation will also address some of the broader spiritual and existential questions raised by the Quran's treatment of time. 1. The Quranic perspective on the flow of time. The Quran presents a nuanced understanding of time, emphasizing its fluidity and relativity. This perspective aligns with modern scientific theories, while also offering spiritual insights. Cyclical and linear time. The Quran acknowledges both cyclical and linear aspects of time. For example, the cycles of day and night, seasons, and human life are described as signs of Allah's creation. Quran 3:27-45-5. At the same time, the Quran emphasizes the linear progression of history and the inevitability of the Day of Judgment, the end of time. The Quran describes the end of time as a moment when the universe will be fundamentally transformed. Verses like Quran 81:1-14 depict the collapse of celestial bodies and the resurrection of humanity, suggesting a radical reordering of space-time. 1. The story of Prophet Solomon and temporal manipulation. The Quran recounts the story of Prophet Sulaiman, who was granted extraordinary abilities by Allah, including control over natural forces and communication with beings from other realms. Some interpretations suggest that these abilities could hint at advanced knowledge of space-time. Control over wind and jinn. Prophet Sulaiman was given the ability to control the wind, Quran 38:36, and command jinn, Quran 34:12-13. These powers could be seen as metaphors for manipulating the fabric of space-time, enabling rapid travel or other extraordinary feats. The throne of Bilqis, the story of the Queen of Sheba's throne being brought to Prophet Sulaiman in an instant, Quran 27:38-40, is often interpreted as a miraculous event. Some modern interpretations suggest that this could involve advanced technology or knowledge of space-time manipulation. 1. The Quran and the multiverse. The Quran's descriptions of creation and the cosmos have led some scholars to draw parallels with the concept of the multiverse, a theoretical framework in modern physics that posits the existence of multiple universes. 7 heavens. The Quran frequently mentions the 7 heavens, for example Quran 67:3, which some interpret as layers of the universe or parallel dimensions. This idea resonates with the multiverse theory, which suggests the existence of multiple, possibly interconnected universes. Alternate realities. The Quran's emphasis on the unseen, or Gaib, and the existence of realms beyond human perception, yet the world of angels and jinn, aligns with the idea of alternate realities or dimensions. 1. Time travel and the concept of qadr, divine decree. The Quran's teachings on divine decree, qadr, raise important questions about the nature of time and human agency. Predestination and free will. The Quran emphasizes that Allah's knowledge encompasses all events, past, present, and future, Quran 57:22. This raises questions about the compatibility of time travel with divine decree. If time travel were possible, would it alter Allah's plan, or would it be part of the predetermined course of events? The illusion of control. The Quran reminds believers that ultimate control over time and events lies with Allah. Verses like Quran 18:23-24 caution against assuming future outcomes, emphasizing the limits of human knowledge and power. 1. The Quranic call to reflect on time. The Quran repeatedly calls on humanity to reflect on the nature of time and its significance in the grand scheme of creation. Surah Al-Asr 103. This short chapter is a profound meditation on time, declaring that humanity is in a state of loss, except for those who believe, do righteous deeds, and encourage one another to truth and patience. It underscores the importance of using time wisely and purposefully. The passage of time as a sign. The Quran describes the passage of time as a sign of Allah's power and wisdom. Verses like Quran 30:50. Observe the effects of Allah's mercy, how He revives the earth after its death. Indeed, He is the reviver of the dead, and He is over all things competent. Encourage believers to reflect on the cyclical nature of time and the renewal of life. 1. Time travel as a spiritual journey. Beyond its physical and scientific dimensions, time travel can also be understood as a metaphor for spiritual growth and transformation. Journey to the divine. The Quran describes the soul's journey toward Allah as a form of temporal progression. Verses like Quran 89:27-30. O soul at peace, return to your Lord, well pleased and pleasing to Him. Suggest that the ultimate destination of this journey is beyond time and space. The night journey, Isra and Miraj. Prophet Muhammad's miraculous journey through the heavens is often interpreted as a spiritual ascent that transcends ordinary temporal boundaries. It serves as a model for believers seeking to elevate their consciousness and draw closer to Allah. 1. The Quran and the future of humanity. The Quran's teachings on time and creation have profound implications for humanity's future, both in this world and the hereafter. The role of technology. While the Quran does not explicitly address modern technology, its emphasis on seeking knowledge, Quran 20:114, and reflecting on creation, Quran 3:190-191, encourages believers to explore the mysteries of the universe, including the nature of time. Preparation for the hereafter. The Quran reminds believers that worldly life is temporary and that the ultimate goal is to prepare for the eternal life of the hereafter. This perspective encourages a balanced approach to time, valuing both worldly achievements and spiritual growth. 1. Conclusion. Time travel as a divine mystery and human aspiration. The Quran's treatment of time is both profound and multifaceted, offering insights that resonate with modern scientific theories while also addressing timeless spiritual truths. While the Quran does not explicitly describe time travel as a scientific concept, its narratives and teachings invite believers to reflect on the nature of time, the relativity of temporal experience, and the extraordinary possibilities that lie beyond human understanding. Whether viewed through a theological, scientific, or philosophical lens, the Quran's exploration of time serves as a reminder of Allah's omnipotence, the transient nature of worldly life, and the eternal reality of the hereafter. Time travel in this context becomes not just a scientific possibility, but a spiritual metaphor for humanity's journey toward divine understanding and eternal fulfillment. As we continue to explore the mysteries of the universe and the teachings of the Quran, the concept of time travel remains a source of inspiration and contemplation, inviting us to ponder the infinite wisdom of Allah and the boundless potential of human aspiration. Certainly. Let's continue to explore the concept of time travel in the Quran by delving deeper into its theological, scientific, and philosophical dimensions. This continuation will also address some of the broader implications of time travel for human understanding and spiritual growth. 1. The Quranic concept of time and human perception. The Quran highlights the limitations of human perception when it comes to understanding time. It emphasizes that while humans experience time in a linear fashion, Allah's knowledge and control over time are absolute. Human limitations. The Quran repeatedly reminds humans of their limited understanding of time and the universe. Verses like Quran 22:47, "A day with your Lord is like 1,000 years of what you count," underscore the vast difference between human and divine perceptions of time. Divine timelessness. Allah is described as being beyond time and space, existing in a state of eternal now. This concept is reflected in verses like Quran 57:3, "He is the first and the last, the ascendant and the intimate, and He is, of all things, knowing." 1. The Quran and the theory of relativity. The Quran's descriptions of time relativity have drawn comparisons to Einstein's theory of relativity, which states that time can vary depending on the observer's frame of reference. Time dilation. The Quranic verses about time differences between earthly and celestial realms align with the concept of time dilation in relativity. For example, the story of the people of the cave, Surah Al-Kahf, describes how they experience time differently while asleep, which can be seen as a form of time dilation. Cosmic time. The Quran's references to the days of creation, for example, Quran 7:54, suggests that time operates differently on a cosmic scale, resonating with the idea that time is not absolute, but relative. 1. The Quran and the concept of eternal life. The Quran's teachings on eternal life in the hereafter provide a profound contrast to the transient nature of worldly time. Timelessness in paradise. The Quran describes paradise as a realm where time as we know it ceases to exist. Believers will experience eternal bliss, free from the constraints of aging, decay, or the passage of time. Quran 44:51-57. Timelessness in hell. Similarly, hell is described as a place where the punishment is eternal and the concept of time is irrelevant. Quran 78:23. 1. The Quran and the philosophy of time. The Quran's treatment of time invites philosophical reflection on the nature of existence, causality, and human purpose. Causality and divine will. The Quran emphasizes that all events are part of Allah's divine plan, raising questions about the nature of causality and human agency. If time travel were possible, would it alter Allah's plan, or would it be part of the predetermined course of events? The purpose of time. The Quran encourages believers to reflect on the purpose of time and to use it wisely in preparation for the hereafter. Verses like Quran 103:1-3, "By time indeed mankind is in loss, except for those who have believed and done righteous deeds," underscore the importance of aligning one's actions with divine guidance. 1. The Quran and the future of scientific exploration. The Quran's emphasis on seeking knowledge and reflecting on creation encourages believers to explore the mysteries of the universe, including the nature of time. The pursuit of knowledge. The Quran repeatedly calls on believers to seek knowledge and reflect on the signs of Allah's creation. Quran 3:190-191. This includes exploring the nature of time and the universe. The role of science. While the Quran is not a scientific textbook, its teachings are compatible with scientific inquiry. The Quran's descriptions of time and creation have inspired comparisons to modern scientific theories, encouraging believers to explore the intersection of faith and science. 1. The Quran and the spiritual dimensions of time. Beyond its physical and scientific dimensions, time in the Quran also has profound spiritual significance. Time as a test. The Quran describes worldly life as a test, with time serving as a measure of human actions and intentions. Quran 67:2. This perspective encourages believers to use their time wisely and to strive for righteousness. Time as a gift. The Quran reminds believers that time is a precious gift from Allah to be used in worship, good deeds, and preparation for the hereafter. Quran 62:10. 1. The Quran and the concept of eternal. Now, the Quran's teachings on divine timelessness suggest that Allah exists in an eternal now, beyond the constraints of past, present, and future. Divine knowledge. The Quran emphasizes that Allah's knowledge encompasses all events, past, present, and future. Quran 57:22. This suggests that from a divine perspective, all moments in time exist simultaneously. Human perception. While humans experience time as a linear progression, the Quran invites believers to reflect on the possibility of a higher, timeless reality. 1. The Quran and the mystery of time. The Quran's treatment of time ultimately points to the mystery and majesty of Allah's creation. It reminds believers that while they can strive to understand the nature of time, ultimate knowledge lies with Allah, the limits of human understanding. The Quran repeatedly emphasizes that human knowledge is limited and that ultimate understanding belongs to Allah. Quran 17:85. This humility encourages believers to seek knowledge while recognizing the boundaries of their understanding. The majesty of creation. The Quran's descriptions of time and creation inspire awe and wonder, reminding believers of the infinite wisdom and power of Allah. Quran 3:190, 191. 1. Conclusion. Time travel as a divine mystery and human aspiration. The Quran's treatment of time is both profound and multifaceted, offering insights that resonate with modern scientific theories while also addressing timeless spiritual truths. While the Quran does not explicitly describe time travel as a scientific concept, its narratives and teachings invite believers to reflect on the nature of time, the relativity of temporal experience, and the extraordinary possibilities that lie beyond human understanding. Whether viewed through a theological, scientific, or philosophical lens, the Quran's exploration of time serves as a reminder of Allah's omnipotence, the transient nature of worldly life, and the eternal reality of the hereafter. Time travel, in this context, becomes not just a scientific possibility, but a spiritual metaphor for humanity's journey toward divine understanding and eternal fulfillment. As we continue to explore the mysteries of the universe and the teachings of the Quran, the concept of time travel remains a source of inspiration and contemplation, inviting us to ponder the infinite wisdom of Allah and the boundless potential of human aspiration. The concept of time has captivated humanity for centuries. It is a subject that has been pondered and debated across cultures and eras, a universal mystery that binds us all. From ancient philosophers to modern physicists, the enigmatic nature of time continues to intrigue and inspire. These thinkers have sought to unravel its secrets, each contributing to our evolving understanding of this profound phenomenon. The Quran, revealed over 1400 years ago, offers profound insights into this fundamental aspect of our existence. Its verses provide a unique perspective that transcends the boundaries of time and space. It invites us to ponder the nature of time, its relativity, and its impact on our understanding of the universe and our place within it. The Quran encourages deep reflection, urging us to look beyond the surface and explore the deeper meanings of our temporal existence. The Quran doesn't present a scientific treatise on time. Instead, it offers a spiritual and philosophical exploration that resonates with the human soul. Instead, it uses evocative language and captivating narratives to awaken our hearts and minds to the mysteries of time. Through its poetic verses, the Quran speaks to the essence of our being, connecting us to the divine. It speaks of time as a creation of God, subject to His will and design. This perspective invites us to see time not just as a sequence of events, but as a divine orchestration that shapes our lives and destinies. The Quran's exploration of time goes beyond a mere chronological understanding. It delves into the spiritual and existential dimensions, of this elusive concept. It challenges us to consider the eternal and the transient, the seen and the unseen. Within the Quran's verses lie glimpses into the malleability of time, suggesting that our linear perception might be just one facet of a grander reality. It hints at the possibility of multiple dimensions and the fluidity of time as we know it. Stories of miraculous events where time seems to bend and warp challenge our conventional understanding and urge us to expand our perception of what's possible. These narratives inspire awe and wonder, reminding us of the limitless power of the divine. This exploration of time within the Quran is not merely an intellectual exercise. It's an invitation to embark on a journey of faith and discovery. It calls us to reflect on our own lives, our choices, and our ultimate purpose. By understanding the Quran's perspective on time, we can gain a deeper appreciation for the power and majesty of our Creator and the true nature of our own existence. It opens our hearts to the infinite possibilities that lie beyond the confines of our temporal world, guiding us towards a more profound spiritual awakening. The Quran, with its poetic language, often alludes to the nature of time in ways that resonate with modern scientific understanding. Its verses, rich in metaphor and meaning, invite readers to ponder the mysteries of the universe and the divine wisdom behind its creation. Consider, for instance, the following verse, which offers profound insights into the concept of time and its fluidity. "And they ask you to hasten the punishment, but Allah will never fail in His promise." This verse speaks to the impatience of people and the certainty of divine timing. "And indeed, a day with your Lord is like 1,000 years of those which you count." Quran 22:47. This verse highlights the relativity of time, suggesting that its passage is not uniform but can vary depending on the frame of reference. This verse highlights the relativity of time, suggesting that its passage is not uniform but can vary depending on the frame of reference. It invites us to reflect on how our perception of time is limited and how divine time operates on a different scale altogether. What we perceive as a vast expanse of time might be but a fleeting moment from a different perspective. This idea encourages us to think beyond our immediate experiences and consider the broader, more complex nature of time. This concept finds resonance in Einstein's theory of relativity, where time is not absolute but relative to the observer's frame of reference. Einstein's groundbreaking work showed that time can stretch and contract, much like the verses of the Quran suggest. Another verse that hints at the elasticity of time states, "He arranges each matter from the heaven to the earth, then it will ascend to him in a day, the extent of which is 1,000 years of those which you count." Quran 32:5. This verse again emphasizes the vast difference between human and divine perceptions of time. Here again, the Quran draws a parallel between different scales of time, implying that the flow of time is not constant but can be experienced differently, depending on the context. It suggests a universe where time is a flexible dimension, much like space. The Quran's verses, while not explicitly scientific, offer glimpses into the nature of time that align with modern scientific thought. They provide a bridge between faith and reason, showing that spiritual texts can coexist with scientific inquiry. This harmony between revelation and reason strengthens our belief in the divine origin of the Quran. It reassures us that the wisdom contained within these ancient texts is timeless, offering insights that remain relevant in our modern world. The Quran is replete with stories of miraculous events that transcend our earthly understanding of time. These stories are not just historical accounts, but are imbued with deep spiritual and moral lessons that continue to inspire and guide believers to this day. These narratives, far from being mere tales, offer profound lessons about the nature of reality and the boundless power of God. They serve as reminders of the divine presence in our lives and the extraordinary ways in which God can intervene in the world. One such story is that of the people of the cave, mentioned in Surah Al-Kahf, the cave. This story has fascinated scholars and believers alike for centuries, offering a glimpse into the miraculous ways in which God protects and guides those who have faith. In this story, a group of young men seeking refuge from religious persecution take shelter in a cave. Their faith and trust in God lead them to a miraculous event that defies human understanding. Through a divine miracle, they are put to sleep for a period of 309 years. This long slumber is a testament to God's power over time and his ability to protect his servants in the most extraordinary ways. Upon waking up, they find themselves in a world drastically different from the one they knew. The society, culture, and even the rulers have changed, yet their faith remains steadfast. This event challenges our linear understanding of time, demonstrating that time can be altered and manipulated according to divine will. It serves as a powerful reminder that God's control over time is absolute and beyond human comprehension. Another captivating narrative is that of Prophet Muhammad's, peace be upon him, miraculous night journey, Al-Isra wal-Miraj. This event is one of the most significant and celebrated miracles in Islamic tradition. In a single night, he was transported from Mecca to Jerusalem and then ascended through the heavens. This journey, both physical and spiritual, underscores the profound connection between the earthly and the divine. During this journey, he encountered previous prophets and received divine revelations. These encounters and revelations further solidified his role as the final prophet and the messenger of God's word. The entire experience, which would typically take months or years to unfold, transpired in a fraction of the time we perceive. This miraculous journey serves as a testament to the limitless power of God and his ability to transcend the boundaries of time and space. These stories, while seemingly defying our understanding of time, underscore a fundamental Quranic principle. God is not bound by the limitations of time and space. He is the master of time, capable of manipulating it as he wills. They remind us of the infinite possibilities that lie within God's power and the profound mysteries that are beyond human understanding. Section 4. Echoes of Eternity, Quranic Insights and Modern Science. The Quran's glimpses into the nature of time resonate surprisingly well with modern scientific discoveries, especially in the realm of physics. Einstein's theory of relativity, for instance, postulates that time is not absolute but is relative to the observer's frame of reference and gravitational field. This concept of time dilation, where time slows down in stronger gravitational fields or at speeds approaching the speed of light, finds echoes in the Quranic verses that allude to the varying perceptions of time. While the Quran does not provide scientific details, its overarching message aligns with the scientific understanding that time is a flexible and relative concept. Furthermore, the Quran's emphasis on God's dominion over time aligns with the scientific understanding of time as a dimension within the fabric of space-time. Just as God is not bound by the limitations of space, he is also not restricted by the constraints of time. This convergence of Quranic insights and modern scientific discoveries underscores that the Quran, revealed in an era devoid of advanced scientific instruments, contains truths that are timeless and universal. It strengthens our conviction that the Quran is indeed the Word of God, revealed to guide humanity towards truth and enlightenment. Section 5. The Divine Clockmaker, God's Knowledge Beyond Time. The Quran's exploration of time extends beyond its physical properties to encompass its theological implications. Central to this understanding is the concept of God's divine knowledge, which transcends the limitations of time. God, being the creator of time, is not bound by its linear progression. He possesses perfect and complete knowledge of the past, present, and future. This concept challenges our human tendency to perceive time as a constraint, reminding us that God operates on a plane beyond our comprehension. The Quran states, "And with him are the keys of the unseen. None knows them except him. And he knows what is on the land and in the sea. Not a leaf falls, but that he knows it, nor a grain in the darkness of the earth, nor anything fresh or dry, but that it is written in a clear record." Quran 6:59. This verse emphasizes that God's knowledge encompasses all of creation, past, present, and future. Nothing escapes his awareness, for he is the knower of all, the one who transcends the boundaries of time.